Have you ever thought of designing a different movement of LED with the CD4017 apart from just doing one thing with it, like the light chaser that we know? Why not stay to the end of this video and see how we could make LEDs move back and forth, as popularly known as the Knight Rider, which uses 6 LEDs. But here we have a problem in the circuit. Do you think it is possible with a CD4017 that counts from 0 to 9 and starts its count all over again? But in the Knight Rider, you see it counting forward and returning backward again. So let's get started. The CD4017 IC with 16 legs, which is output from 0 to 9. Now you could see that we have 10 LEDs at the output of this CD4017. But think of it this way: what if we just divide their output and then take the second half of this output of this IC and then feed them back to the first half of this output with a diode? So the diode there is the key player of this back and forth movement. So whenever the IC has reached its 5th count and wants to move to the 6th count, since the 6th count to the 9th count has been fed back to these LEDs, it will be counting backward. So the purpose of those diodes at the output is just to prevent reverse current from the other output. So without these diodes, the reverse current from the other output entering the next output would destroy this IC. So let's get started. So with my jumper wire, I then place pin number 13 and pin number 15 to pin number 8, which happens to be the ground pin, and place the next jumper wire, which is pin number 16, to the positive rail, and then place a jumper wire to pin 8 and the negative rail, which we are going to use for our 5-volt power supply, and then place all 6 LEDs on the breadboard and given a space between them. And we are using a common cathode configuration, and also place all 6 diodes accordingly in series with all the LEDs. So with this LED is going to move forward. So now we are going to do for the backward count, starting from the second LED to the second to the last, with their anodes separated from each other and their cathodes pairing one LED. Place a jumper wire between the pin 3 and the first diode, and then pin 2 to the second diode. Also connecting pin 4 to the third diode, and also pin 7 to the 4th diode, and also connecting pin 10 to the 5th diode. And finally, with our forward count, place a jumper wire between pin 1 and the 6th diode. Now over to the reverse count, place a jumper wire between the second to the last diode to the 5th pin of the IC, and as well connecting pin 6 to the 3rd to the last diode, and also connecting pin 9 to the 3rd to the last diode, and with the 4th diode in line, connecting it to pin 11, and place a push button switch as I did close to the CD4017, and connecting pin number 14 to the first lead and taking the second lead to the power supply rail. I then plug in my power supply using a 6-volt. And you will notice each time I create a pulse signal into the pin number 14 of the IC, you will notice the changes in the LEDs. But here is it: we can't keep doing this thing manually with our hands. We need something to operate this automatically. So in this case, we are going to need the NE555 timer IC. Connecting pin 4 to pin 8 of the 55 timer IC. After then, place a jumper wire between pin 2 and pin 6 of the 55 timer IC. And you can see I've done that, connecting pin 2 and pin 6, and also pin 4 and 8 connected, and also connecting pin 1 to ground and connecting pin 8 to the positive rail, and also placing a 1k resistor between the positive rail and pin 7. After that, I then place a 20k ohms variable resistor between pin 7 and pin 6 of the IC. And as you can see, I've already bent one of the leads so that they won't have contact with the other pins. After then, I then place a 10 UF capacitor between the pin 2 and ground, and take the output of the pin 3 of the 55 timer IC and feed it into the pin 14 of the CD4017 IC. After then, I then hook up my 6V power supply into their power rails. And after then, you can see our LEDs moving back and forth. Not quite done. After some moments, I noticed that the LED stopped flashing. I then changed the variable resistor, as you can see. And then varying this variable resistor, you can see we can increase the speed or decrease the speed of our LEDs. And also, please do not forget to hit that subscribe button and keep your notification bell on so that anytime I do upload a new video, you wouldn't miss that video. And also like and share this video with your friends, and don't forget to drop a comment on the description box below so that I can see what your thoughts are about this video. I then fix in these beautiful bits into the LEDs that I got from a cosmetic shop that I approached and saw this and thought of it as using to design this K-Night Rider. And I saw it as a nice thing. So do not forget also to give me a like. And also note this, changing the value of the capacitor also has an effect to the speed of these LEDs. And also stay innovative and also think of more ideas on how to do something. And I do love you guys, and I will see you next time.